Hello and welcome back to AP Environmental Science. Today I want to talk about air pollution. And I think these are some great pictures for two reasons. Only one of them actually shows, well, sort of, shows real pollution. The other ones are showing mostly condensation. So two things I want you to walk away with today. One, an understanding of air pollution, and two, a critical eye to photos that make you think one thing when really you're seeing something else, right? So this is all water vapor, it's condensation, all that good stuff. This is all water vapor. None of this is pollution. Now, that doesn't mean that in this picture there aren't pollutants in this, but in fact, there probably are not that many, right? Now, this picture, on the other hand, you can see lots of water vapor, but you can also see all of this smog here. So this is pollution and water vapor. And then, of course, here you have the smog and the particulates that you can actually see the rays of the sun reflected off this building. It's a cool picture. It's also a very sad picture because of that, I have to say. But anyway, air pollution. So what are we talking about when we talk about air pollution? It's probably pretty obvious, and I think this picture is really strong in that. These are these beautiful white fluffy clouds, and here is the brown yucky pollution layer. And this is the smog layer, and we can see a whole lot about pollution from space. I mean, obviously we're in it most of the time, but I think sometimes it's hard to tell exactly how polluted the atmosphere can be. Here you have all of these toxic clouds of air pollution. And that's the interesting thing about satellites, right, is that we can see so many things GIS. We can see so many things that we could never see before, and sometimes they're pretty frightening. So we can kind of divide air pollution up into about four different kind of ranges, scales, right? We've got global, and when we talk about global air pollution, we're talking mostly about global climate change and stratospheric ozone depletion, okay? When we talk about regional, we're talking about transporting pollution from one area to another. For instance, China exports lots and lots of air pollution to the west coast of the United States. Acid rain, there was a very famous case or I think it was the state of Georgia, like 1907, sued the Tennessee Valley Authority for acid rain coming out of the stacks and things. Local, right? So you're talking about city air quality, so urban smog, urban air quality. And then, of course, there's indoor air pollution, and I think this is the one that people don't really know a lot about, but we are going to spend a whole day talking just about indoor air pollution. Okay, so what are we talking about when we talk about air pollution in terms of the actual chemistry, right? Well, first of all, there are primary pollutants and there are secondary pollutants, and we're going to define both of those in just a minute. But all of this stuff is anthropogenic. It's coming from things that we're doing, whether it is industrial stacks or incinerators or vehicles, right? Combustion engines, could be from burning coal or oil or natural gas, whatever. It's a real problem, and the World Health Organization estimates the number of premature deaths because of exposure to air pollutants to be about 50,000, 175,000, a million, or 7 million. Globally, we lose about 7 million people prematurely because of air pollution. Okay, so what determines how much air pollution you're going to be exposed to? Well, first of all, obviously, it's the amount of pollution that's entering the air. It's also going to be the amount of space. Concentrations will go down if you have a larger amount of space into which the pollutant has been dispersed, right? And then, of course, some pollutants are actually scrubbed out of the air faster than others. Some are persistent. I mean, if you think back to our CFCs, they're persistent. They last for, 100 years. But some things fall out pretty quickly, like sulfur dioxide forms sulfuric acid and rains out fairly quickly within a couple of days, a week, a couple of weeks. So it really depends on what you're talking about and how it works in the atmosphere. And that brings us to the air quality index. There are different levels, and you see these on the news. If you're watching the weather or whatever, they'll say, oh, it's a purple day or it's a red day. This is what it means, and I put in here you could see what you should be doing and who's going to be affected by whatever the actual rating is. Very rarely do we get green days in the city. And here I put in a little link, this on your PowerPoint, that you can actually check our local air quality, or yours, wherever you happen to be, and see what is going on there. Okay, so mechanisms that remove pollutants from the air, I mentioned that as the last thing. Dispersion, it can. I mean, it definitely makes less concentration. Dispersion is not the answer though, because it just spreads the pollutant out. It doesn't make it go away, but it can lower concentration. Deposition and fallout, that actually does mean that it leaves the atmosphere. Some chemical reactions break down things. I mean, we saw that with the ozone. One chlorine molecule can destroy 100,000 ozone molecules, right? And then also the anthropogenic enhancement of sinks. What does that mean? It means that we put things out there that will take pollutants out of the atmosphere, and we can do that in terms of scrubbers and precipitators for actual pollutants. And then for something that is not a pollutant, right, CO2, we can have sinks, more green spaces, things like that. And also, don't forget phytoremediation. Plants can help filter the air as well of pollutants, not just CO2, but pollutants too. Okay, so which country is the biggest air polluter? The United States, India, China, Russia, or Mexico? You might be tempted to say the United States, and about 5 years ago you would have been correct, but China has, within the last few years, become the largest air polluter in the world. Okay, so what is the impact of air pollution? And that's why I mentioned China earlier, by the way. Exporting its pollution, it comes over on air currents and things. But why does it matter? What's the impact of air pollutants on natural environments? There's the health issues that we've talked about and we're going to continue to talk about. But also, you're talking about water contamination. This is a water quality issue because of fallout and precipitation. Animals and plants are susceptible to pollution too. I mean, animals get cancer, animals get respiratory illness, animals have heart failure, they have all of those things. Plants, some of the chemicals, the air pollutants, break down chlorophyll, and so you have chlorosis, and that's what you're seeing right here. A plant that doesn't have chlorophyll can't do photosynthesis and is going to die. Also, some of these pollutants actually destroy cells. I mean, think about ozone. Ozone destroys cells, and so you get necrosis, in plants. Also, there are just some other things. That would be visibility. You can't see anything. I mean, that is an aesthetic issue for the most part in terms of just being able to see for many people, but there are some real hazards to that as well. I mean, what if you cannot see long distances and you're, say, like, an airplane where you might want to see other airplanes? That becomes an issue. And also, the quality of the things around you, right? You get loss of color of things, oxidation, corrosion, acid rain will eat away stone, and this seems also like an aesthetic thing, but there's a real problem here too, and it has to do with economics. There is a decreased real estate value, and here's a really good example. You can see this little townhouse building here. This side is pre-clean, so the owners of this one have not cleaned it. The owners of this one decided they would clean the building to its original state. There's a huge difference. People are going to pay more for this than they are for this. This building is white up here, right? And this is actually what? I don't even know. Who knows? It's a person. Yay. Is it? Or is it a coat of arms? Oh, tricky. Who knows? You don't know because you can't tell. Okay, and also our own Statue of Liberty, right? Beautiful copper color, green. Now, a lot of this has to do with sea air, right? And so this kind of a situation is not what I am talking about when I talk about air pollution, okay? Just this going to the green, people are like, air pollution. It's not. That's not a pollution thing. This is an oxidation thing, okay? It's because of the natural sea air that's happening there. However, having said that, there are some real problems with pollution in this situation. And that is, you can see that the metal's being eaten away. You've got the black layer forming. This part actually is a problem. The green patina actually protects the metal, and that's pretty helpful. But the black part, that's a problem. And so our very symbol of freedom and the United States is actually being eaten away by our own pollution tendencies. It's a little bit sad. Okay, true or false? There are threshold levels of tolerable air pollutants. That is false. Guys, if it were tolerable, it wouldn't be a pollutant, okay? How about this one? Dilution is the solution to air pollution. It sounds very catchy, and no, it is not. All you're doing is spreading it out. I mean, yeah, it's in a lower concentration, but you're spreading it out. How about this one? Air pollutants can be assimilated by nature. Yes, they can. Nature has an amazing way of cleaning up after us, right? Now, we push that to the limits frequently, okay? But like I said, nature has a good way of cleaning up. How about this? Air pollutants don't travel. They just hang out where they are. Totally false. They travel all over the world, and I'd like to recall China and the United States there, okay? Air pollution accidents don't happen. Oh, no, they totally do, and we're going to talk about those in just a second. But here's the thing that we want to talk about now. What are the major air pollutants? We don't really know if they're going to be a problem until we know what they are. So the primary pollutants, remember I told you there were primary pollutants and secondary pollutants. The primary pollutants are going to be those that are directly derived from the emissions, okay? Usually that's going to be burning fuels and wastes, and they come in several forms, but the big ones are going to be particulates, your hydrocarbons, which we talked about, better known as VOCs in this case, carbon monoxide, nitrogen oxides, and your sulfur oxides, okay? And here are just some examples. Here you've got all kinds of stuff, a lot of particulate situation, okay? Which primary pollutant forms secondary pollutants and contributes to acid rain? Now I will tell you on this list, a couple of things actually form secondary pollutants, right? Only one of them does both. Oh, and one of these things is a secondary pollutant, by the way. So we already had a conversation about VOCs. We know that VOCs and nitrogen oxides mix together to form ozone, but they don't actually form acid rain. Sulfur dioxide forms acid precipitation, and the acid is a secondary pollutant. So the answer here is sulfur dioxide. Radon and lead are primary pollutants, and ozone is a secondary pollutant. So, ozone, PANs and acids, right? Those are the secondary pollutants that we want to know, okay? All right, and here I just put this in here so you can kind of see where everything is coming from. Sulfur dioxide and nitrogen oxides come predominantly from fuel combustion. Your VOCs are industrial processes and transportation. Nitrogen oxides also from transportation, and carbon monoxide, actually. And then for your particulates, this can be any number of things: fires, dust, industrial processes, you know, whatever. Now, the EPA has identified 6 criteria pollutants. Some of them are primary, some are secondary, but these are the things that the EPA thinks are the most dangerous or most common, most important, most significant pollutants. And that is ozone, which includes VOCs, particulate matter, nitrogen oxides, sulfur dioxide, carbon monoxide, and lead. Okay, and I put this in here. We've talked a little bit about all these other ones, but particulate matter, what is that? These are really tiny particles. This cylinder right here is a human hair. These are the particulate sizes that we're talking about, 10 microns, right, or less. Okay, and so that's kind of where we're going with that. And here's a little how big are things in your house, and then, yeah, see, look, here's a human hair, 10 microns, right? So we're looking for things that are smaller than that. And then here are some filters and how efficient they are in terms of what they're doing. That's just for you to look at. Okay, and then here's some information about each of those 6 criteria pollutants. Read this, understand it. If you have any questions, please let me know. So, those are the 6 criteria pollutants. Which chemical do some scientists think should be added to the EPA list of criteria pollutants? Mercury, radon, carbon dioxide, or formaldehyde? Well, radon is an air pollutant, right? Formaldehyde is an air pollutant. Mercury can be, mostly we consider that a water pollutant, but it can be vaporized. And radon and formaldehyde we'll talk about later. They're absolutely on the list of air pollutants. They are not one of the 6 criteria, but there are a lot more pollutants than just those 6, yeah? But carbon dioxide is the only thing on this list that's not a pollutant. And that kind of brings us to the idea of what is a pollutant. And we talked about that when we talked about water. carbon dioxide is not toxic, right? It doesn't cause degradation, right? It doesn't do any of those things. And as a matter of fact, we exhale it. And so it would be very difficult to classify that as a pollutant. However, we do need to do something about carbon dioxide because it is a powerful greenhouse gas, and we emit lots. Actually, it's not that powerful greenhouse gas. I take that back. It's an okay greenhouse gas, but we emit lots of it. So, there you go. And so it really is having an impact on the ecosystems. Different people argue as to whether that's an okay thing or a not okay thing. The fact is that it is happening. It is changing the global climate. But the argument to make it a pollutant, that has some real serious ramifications for all kinds of things. I mean, now we're starting to talk about social impacts, economic impacts, political impacts. And so when people say that, I want you to really seriously think that out. Think it through. What does that end up looking like? And I'm not saying that carbon dioxide gets a pass, because again, we need to figure something out about that because global climate change. But the question becomes, would it be a good would it be good to list it as a pollutant? All right, so listing things as pollutants comes under the Clean Air Act, right? And this identifies the most widespread pollutants. That's the criteria pollutants. It does some other things. It sets the rules and all that good stuff. But what you need to know is that pretty much anything that goes with air quality is going to fall under the Clean Air Act. And then the National Ambient Air Quality Standards, that's like the Safe Drinking Water Act for air. It's what sets the actual standards. So just like the Clean Water Act identified and regulated water stuff, the Clean Air Act does that for air. Safe Drinking Water Act and the National Ambient Air Quality Standards are the same kind of thing too, okay? All right, so which of the following criteria air pollutant, I don't know why I have it written like that, that's crazy, has decreased the most since 1982? Particulate matter, sulfur dioxide, nitrogen dioxide, carbon monoxide, or lead? Well, I can tell you right now, it's not particulates, it's not carbon monoxide, and it's certainly not nitrogen dioxide. Coal companies have really good scrubbers for sulfur, and so that's something that's under control. It's not decreased because we keep burning more and more coal. But what has decreased is lead. And the reason that lead has decreased so much is because we banned leaded gasoline. It's another event which everybody came together and said, this thing is bad, we're going to do something about it, and we did. The majority of countries in the world anymore do not use leaded gasoline. Okay, and so you can see overall, actually, cars have gotten better because emission standards have gone up because people want cleaner cars. But lead is really that very good example. Hydrocarbons, carbon monoxide, nitrogen oxides, these are the things that are coming from, especially these two, from those incomplete burns. So as engines become more efficient, these two things go down, and the benefit of a more efficient engine is that you get higher gas mileage, you have to pay less for gas, and people want that. Okay, so let's talk about accidents. This is the last thing we're going to talk about. But earlier I said air pollution accidents don't happen. Well, we know that we've got water pollution accidents, we've got oil spills and tankers rupture and all kinds of things. But what about the air? It turns out that air pollution accidents happen too, although they happen differently than, like ruptured train or crashed train cars or, oil rigs breaking or whatever. In this case, you need some sort of atmospheric component to help for the most part. There are definitely times when that's not true, but many air pollution accidents have had this whole temperature inversion situation. And the idea of having lots of pollutants in the air and stagnant air, that's what a temperature inversion does, it causes stagnant air, came really to light in the Donora death fog in 1948, and this was in Donora, Pennsylvania. This is a picture that was taken at noon. You can see that it's black as night, right? I mean, it looks like the middle of the night. And so what happened is this temperature inversion acts like a cap. And an inversion is where you have cooler air, warmer air, and then cooler air on top of that. And so it forms like this little sandwich cap. And so you don't get any airflow. And so all of the fluoride emissions from U.S. Steel smelting plants in Donora actually sat over the town, just like in that picture, for 4 days. And about 20 people died, and lots of other people had respiratory and cardiac issues because of that, right? Hundreds of people. So that was really the first indicator that things were going horribly wrong, at least in the United States, okay? In Mexico and New York, we had two more killer smogs in the 50s, again from refineries and industrial, and again with temperature inversions. This is a daytime picture taken in New York of the killer smog there, and that killed somewhere around 200 or more people. In Mexico, you had 22, but by the time you get to the New York one, you're talking about lots of people dying, and it gets even worse. In 1952, which was before the New York, but still, in London, 4,000 people died in what they call the Great Smog, respiratory and cardiac failure, right? In 1956, they have it again, and 1,000 people die, right? This is London at 10:30 in the morning. That's crazy. Okay, same thing. You have that high pressure system, the temperature inversion, settling over the city, trapping pollution near the ground. Okay, and remember, respiratory distress often causes heart failure, right? Those two things are very linked. The respiratory system and the circulatory system, really linked. And here's just some more pictures of that. I mean, that's crazy. All right, and this is London today. You can see that its air quality has gotten so much better. Oh, wait, no. London still has lots of air pollution issues. Started out early on with coal-fired industry, but it's not gotten any better, and now you're starting to see actual photochemical smog, which we'll talk about later on. Okay. Now, other things happen too. Sometimes you have gas leaks, right? And a really tragic event in 1984, the Union Carbide insecticide plant had a leak, and this pesticide washed over this city and killed well over 2,000 people, and somewhere between 150,000 and 300,000 people had respiratory issues after that. And so in this case, there's not a climate thing. You just have this cloud, but this cloud was more dense, and so it traveled along the surface, and it just killed everybody in the village outside of the Union Carbide plant. And then fires. When we have big fires, they also can create killer smogs because of the particulates, mostly is what's related there, is what's the problem there. And you can see, look at this. And this is all particulate stuff, and in addition to particulates, you have the chemicals that are being released from whatever's being burned. And so you have this double whammy of pollutants and particulates. I mean, particulates is a pollutant too, but chemical pollutants and particulates. And these were not that long ago, 2005, where you had these out-of-control forest fires. And a real problem with fires is that they are increasing in number in many areas. In Australia, for instance, they've had some of the worst wildfire seasons they've ever had in the last 10 years. And that's because global climate change is making for more extreme weather conditions. And so it's very possible that we can expect more fires in the future, which means more killer smogs. All right, so that's it for this set for air pollutants and all that good stuff. If you have any questions, please let me know at the beginning of class, and I will see you next time. Thanks for listening.